Start recording. Here we go. Today we're looking at arrays. What is an array in C++? So let's look at that. Some examples of arrays and when they're useful. Okay. Now let's suppose I'm going to make some sort of project where I need 10 integers. Okay. Now I could go num1 like this, int num2 like that, and just keep going, right? And all the way up to num10, etc., etc. And then if I wanted to set those 10 integers, I would also need 10 lines of code. And maybe even I ask the person to type all 10 in with a cin command. Then I will need 10 of those as well. And you can see that that starts to make your code look pretty bloated. And now you got 10 variables to keep track of. And that's going to be a pain in the butt for you. And let's suppose your program gets bigger later on, and it's like taking in student IDs or something, and now all of a sudden you have 1,800 of them. Are you going to make 1,800 variables? The answer is no. The answer is you make one variable name, but you put how many you want it to hold in square brackets afterwards. So this variable now can hold 1,800 integers. Okay?
What's the limit?
It depends on your computer and the memory in your computer. I wouldn't do any more than maybe like 10,000 or something. Okay. Could get super inefficient because you got to save it all in memory. But I have 1,800 right now, and if I stop my program and see what that variable looks like under the watches command, let's have a look and see if it's got a spot for 1,800 here. Yep, it's running. If I go to watches here, you can see that num1 is just one variable, but it holds 1,800 things. By the way, look at what they're all filled with. Just nonsense. Okay? We've talked about this in the past, but a computer, when it goes to store spot to hold a number or any kind of variable, it just takes an empty spot of memory that's not being used. It doesn't necessarily mean they're all filled with zeros. It just, whatever junk is in them is what it keeps. So you can see all these funny numbers in there. It just found a spot in your memory where there was 1,800 gaps in a row, grabbed it, and it was filled with junk. But you could see it only shows up to 200 in the debugger. What are some other interesting factoids about this?
Why not more?
Well, it's not going to show 1,800 probably just for efficiency reasons, because it figures you're not going to want to look at all 1,800, right? Make a big list. I'm sure you could change that. Look at the first one. It is indexed at the number 0. Okay? The second one is indexed at the number 1. The third one is indexed at the number 2, and so on and so forth. So using that as a clue, I'll show you how to set variables in this array. Do I want 1,800? Probably not for now. Maybe I'll go back to my original 10 that I was thinking about doing. And instead, if I want to access the first one, I just write in square brackets 0, and then I could let that equal the number 1. And then num2 or num1, it just saves me a bunch of lines having to make 10 variables, right? So if I copy and paste all this, let's say I want to fill it up with the numbers 1 through 10. So I would do 2 like that. I would make it equal 3. I would have the fourth one equal 4. Now the fourth one is actually indexed at 3 because 0 is the first index. So you can convince yourself of that. All right, 5 and so on and so forth. Let me just copy and paste all those and quickly write. This is kind of an inefficient way of setting an array of variables as well. We'll find a better way to do that in a minute. Okay. So 6, 7, 8, 9, and 10. There you go. It's still an inefficient way, but it has saved us 10 lines of code because we didn't have to make 10 variables, right? We just have one variable name that can hold 10 things. So that could be handy. Let's look at it under the watches window and see if it's filled with the numbers 1 through 10. Hopefully it should be, as long as we did our code correct. Yep. We just zoom in on that. You can see it's the numbers 1 through 10. Okay? And it starts at 0 and goes till 9. Now, so that's all good. I wonder, even though I've said I only want 10, I wonder if I put an 11th, will it complain to me? If I say num1 and then index it at 10, which means it's the 11th, will it let me do that? Let me run it and see if I get any errors. I get no errors, okay? It is a dangerous game to play though, because I did tell the computer I only need space for 10. All right. Yes, I could make the 11th one equal 11, you know, but if that memory is being used somewhere else, that could crash my program. That's a very dangerous thing to do. Okay, so be careful with going out of index on these. It will let you do it. It's not going to argue with you, but it can be a dangerous thing to do. Here are some, so that's kind of the benefit of an array. I'll show you using a for loop. They go really well with for loops, because if I start a for loop at 0 and I make it go up to 10 like that, and then I make it increase, I can actually set this variable like this, because I will count from 0 to 9, right? So that will run that code 10 times. And if I say let it equal I plus 1 like that, then I don't need any of this code. I can get rid of it. So they work really well with for loops, because for loops count from, you know, for loops are really good at counting. And so setting your variable, you could even put it like a CIN in here and do CIN num1 I like that, and then you could have the person type in all 10 numbers as well. So they work really handily with for loops. Okay, if I run this, I will see that that array is filled with the numbers 1 through 10. I did I plus 1 because it started at 0, but if I run that again, I can see it's just filled with the numbers 1 through 10. And I could actually fill up my array. I could actually make this 1800 now and make this 1800. And it would fill it up with the numbers 1 through 1800. Okay, so that's an efficiency thing. I've just made 1800 variables and filled them all up, but I've only used 1, 2, 3, 4, 5 lines of code. Yeah, all it is a convenience thing for you, especially if we make a project that's got to hold a lot of stuff. There you go. It is holding the numbers 1 through 1800 if I need them for something. Okay, it's mostly good for like collecting data and doing, you know, maybe collecting a sound file. Every piece of sound file is like a voltage that goes to your speaker, and you need like 4,400 of them a second. You would store them all in an array and print and have them, you know, played out to a speaker or something. So that's the power of the array. That lab's going to ask you a few questions about an array. Couple bad things about an array, and we're going to use like a more, I would say, a more user-friendly type of array in the next lab. It's because once we make this array, we can't change the size of it later on. As soon as you tell the computer you need 1800 spots, that's it. Okay? You can't go and erase one out of there. It's not going to let you do that. It's
Can you not change that right now?
what?
Can you not change that right now? Like right now you can do it, right?
I could do it here, but let's say like my program requires that I need to get rid of num1 and like, let's say I'm running through a list of like maximum numbers or something, and I need to pop off the 1651st piece of that array. I just want it out of the list, so that my array is only going to be 799 long. You can't do that with this simple C++ array. We'll use something a little more user-friendly in the next lab. It's called a vector. It allows you to pull stuff out of the array and erase it, get rid of it. It allows you to add extras on. This is the other thing. I can go and write 1801 and let it equal something, but that's a very risky operation because I asked the computer for 1800 of them, If I try to tack more on, if that space is available, it might let me. If it's not, it will crash. So there's no way to like add more stuff to an array. And the last thing is, I know the size is 1800, but let's say this is growing and shrinking, and let's say I somehow figure out how to grow the array when I need it or shrink it when I need it. How do I keep track of its size? I would need a variable to keep track of its size, and that's just more coding overhead. The other array type we're going to use in the next lab will keep track of how big it is. It will keep track of we can like put algorithms on it to sort it and figure out what's the biggest element, and there's all kinds of nice options for that. We'll also be able to take stuff out of it, add stuff onto it, all at the cost of a little bit of speed in our programs. But that's speed we won't notice because we're not running anything intensive. So the arrays are cool to know, but we try to stay away from them as much as possible unless we're making something very simple that's going to hold a few little items. I think the best use for an array is like to make a 2D number, you know. You could have like an int point and make it hold two things, like an x and a y, right? So you know point 0 holds your x location and point y holds your point 1 holds your y location, kind of thing. That's when the simple array is going to be pretty useful. Other than that, we're going to stick to a different type of array coming up. C++ calls it a vector, which is kind of an awkward term since we're using vectors at SFML. But try that lab out. Have a look at it. You'll see that a string is actually a built-in array. So if I write name1 like that, make name1 equal hello, you should be able to see that a string is just an array of characters. So if I write 0 here, that should put an H on the screen, right? Will it? Sorry, that's not good code. Will it write H on the screen? Yes, it does. Okay, yeah. If I write 4 here, it should write an O because that's the 5th letter. And it does write an O. If I write 5 here, it might just write junk because it'll find some variable in that area. Oh, there's nothing in there. Don't write 5 because there is only 5 letters, but 4th is the last letter. It's a little confusing, I know. You'll get used to it. So try lab on arrays in the Google Classroom, okay?